And I always draw my picture the same way every time to make sure that so I'm going to put my angle, I always put the angle right here in the corner. And then this is the side that goes opposite that. And then this is the side that goes here. So I'm going to set this up with law of sines, okay? Because I can use law of sines with this. So I do sine of 117.32 over 67.25, sorry about all the decimals, is sine of A over 15.05. So the difference here is I have sine of A. So I'm going to have to solve for A by doing inverse sine. And that's where I run into trouble, because when I do inverse sine on my calculator, sine is that friend that only tells you half of the truth. It's only going to give you that angle. But it could also be positive over here. This is an obtuse angle, and this is an acute angle. So I have to figure out for myself if the angle that I'm solving for could be obtuse. So look at this picture and tell me if A could be obtuse. Well, in the first place, it can't be obtuse because B is already obtuse, and I can't have two obtuse angles. And another way is this is bigger. Because this is bigger, I know that A is less than this angle, because 67.25 is greater than 15.05. So that means the measure of angle A is, or the measure of angle B, sorry, is greater than the measure of angle A. So that means angle A can't be obtuse. So now I just use my calculator to solve this. Now I put it in my calculator and I do 15.05. I make my loop with the two that I can loop, times sine of 117.32, and divide it by 67.25. Now be careful, because this equals sine of A. So I'm going to have to do something when I do that. So I put that in my calculator, and give me a second, I did not put this in my calculator. You put it in your calculator as I am. Sine of 117.32, and divide it by 67.25, and I get 0.1988 equals sine of A. So now how do I get A by itself? I'm going to do inverse sine of this on my calculator. So I'm just going to do inverse sine of the answer, because that's already in my calculator. Inverse sine of the answer. So on these ones, when you're solving for an angle, you're going to have to do inverse sine. And I got 11.5 for my angle here, which makes sense because this is way smaller than that, isn't it? Okay. Now I can solve for the other angle by adding them up. Add these two up. The sum of the angles is 180. And for angle C, I got 51.2. And now I can use that to find side C, can't I? So I'm gonna take this off and, well, no, let's just put this over here. Sorry. Let's put it over here. So I'm going to use the same proportion, sine of 117.32 over 67.25 equals sine of C, which is 51.2 over C. Now I'm going to cross multiply this way. This is all in the notes if you want to look at the notes, and then divide it by that. And so for side C, I got 59. And that's about right, because this angle's in between these two and this side's in between those two. Okay? Okay, let's try another one. So I draw my picture. I have angle B is 52.7 degrees. Side B is 12.3. Side C, I always want to draw it like this. So I have angle side this way, okay? So it matches what they gave me in the, okay? So now I'm going to set up my proportion for, this is angle A. So I have sine of 52.7 over 12.3 equals sine of C over 16.3. Okay, now let's look at this. Could this angle right here be obtuse? I can tell by looking at this picture that the measure of angle C is greater than 52.7. Because 16.3 is bigger than 12.3, so angle C has to be bigger than this angle. So that means it could be obtuse. So what I'm going to do is let my calculator figure this out for me and see, I either have one triangle or two triangles, and I'm going to try and figure this out, or no triangles, okay? So I'm going to put this in my calculator, and I'm going to do 16.3 times sine of 52.7 over 12.3, and that's going to equal sine of C, right? So when I put that in my calculator, I get times divided by 12.3, I get 1.05 is sine of C. Now when I try and do inverse sine of this, what's going to happen? I can't do inverse sine of an angle bigger than, or a proportion bigger than 1. So this doesn't work, so that's how I know there's no solution. So I just let the law of sines tell me, I just set it up and see, it could be obtuse, but it's not going to be anything because this side, 12.3, is too short to even reach the base of BC. So this is no solution or no triangle.